In this section, we're going to study the application of linear systems. So any word problems, this is a very general step that you need to consider when you solve word problems. Step 1, define the problem. We need to identify what you need and what you have, what other information is available to help you define it. Second step is assign variables. Choose the variables that describe each unknown quantity. Step 3, translate into the system of equation. Then solve the problem using either graphing, substitution, or addition or elimination to solve the system. Check your answer and answer the question. So let's look at example 1. I will show you how to use this step to solve the problem. Now, when you read a word problem, sometimes it sounds very strange. It's always helpful to read a couple of times to help you get an idea what they're asking you. So that's what I usually do. So the question is, here's the problem. The sum of the ages of Ben and his younger sister Anne is 18 years. The difference of their age 7 years. What is the age of each child? So it is the age problem between Ben and sister. So what we do is we know that these are all information that the sum of the two is 18 and the difference is 4 years. And step 2, I want to assign variables for our problem. We're looking for the age of Ben and Anne. So I'm going to let B stand for Ben's age, and let A stand for Anne's age. So the first sentence, now step 3 is we're going to translate all the information into the equation. The first equation here is say the sum means addition. The sum of the ages of Ben and his sister is 18. The is here actually mean equal. So B, sum mean plus B plus A is mean equal to 18. That is the first sentence that we translate. The second sentence says the difference. The difference means subtraction. The difference between their age. So it means B minus A. So have B minus A equal to this means the difference is 4 years apart. So you have 4 equal to 4. Now, step 4, we have to determine which system you want to use, which method you want to use to solve for the equation. You can use either graph, you can use substitution, or addition. Well, in this problem here, I found that you eyeball these two equations here quickly. if you see that if I add the two equations together, the A cancel out. So why not using addition method? It's easy. So I'm going to add it together. So when this here added together, you have 2b. Now this a plus a here minus a here become 0. So we don't have to write it down. Then 12 plus 4 is 22. To solve for b and divide by 2 both sides. Okay. So the 2 here get cancel out. So b equal to 11. Okay, because 22 divided by 2 is 11. So here is band H is 11. Okay, now to solve for NH, you can go back to these two equations. You can use either or of the two equations and solve for NH or A. But you know that, well, you can do it in your head. Or you can just say, well, you use the second equation here. If B is 11, then this equation here become 11 minus A equal to 4. And you can minus 11 both sides. So minus A equal to minus 11. And multiply both sides by minus number, minus 1, to cancel this minus side out. So A equal to 7. So this is your answer. N is 7 years old and Ben is 11. Okay? So that's the answer. Now look at another example. So the display panel of a graphing calculator has the shape of a rectangle with the parameter of 264 millimeters. If the length of the display panel is 18 millimeters longer than the width, find its dimensions. Okay, step 1, they ask us to find the width and the length. That is our step 1. Step 2, we're going to assign the variable for we're looking for that. So we will let L stand for the length. And I'll let W stand for the width. So that will be the variable. Okay. Alright. Now, it's a rectangle. And it tells us that the parameter of the rectangle is 264. So let's see. Here, let's say I have a rectangle. The parameter means a distance around the rectangle, which is equal to 264 millimeter. I won't write down, but let's write down now so you can see. And what we learned from geometry, we learned that the parameter of the rectangle is 2W plus 2 is the length. So right here is the length, and right here is the width. Okay, you have two of those, one on top, one on the side. Right? So they give us the parameter, which is 264. So I mean 264 is the parameter has to be equal to 2W plus 2 length, 2L. Okay? Now, that is the first information that they give us, the parameter. They say that if the length of the display panel is 18 millimeters longer than the width. Now, let's try to translate this into the equation. We let the length stand for L. Okay, so I have this, the length is stand for L. L is equal to 18 longer than the width. The width is W, so 18 longer than the width means the width plus 18. Now we have two equations. Here's the first one right here. Here is the first equation, and here is the second equation that we have. Okay. Now let's see. Step 4 is we need to decide which methods you want to solve, either using the graph. Graph is kind of messy. I prefer to use either substitution or addition. So let's look at the problem. Let's see which method to look at. I see that I have the variable L is equal to something else, so I'm going to use substitution method to solve this problem. Okay. So I'm going to do. I'm take the L variable here, substitute inside this L here. So now let me rewrite the equation. 264 equal to 2W plus 2 times L. But L is what? L is equal to W plus 18. That is L. So now let's simplify this equation and solve for W. Oh, I put too many equal sign here. Excuse me. There you go. So you have 264 equal to 2W plus 2W distributed the 2 inside there. So 2 times 18 is 36. So now continue simplify. 2W plus 2W is 4W plus 36. To solve for W, and minus 36 both sides. So 264 minus 36 equal to 8 here, 2 here, and 2 there. Then to solve for W, we divide by 4. Okay. Four go to here 5 times. 2 left. Bring out the 8. 4 go and say 7 times. So our answer will be 57. Now, if you know the width, we can always solve for the length. Because when we go back here, remember the length is equal to width plus 18. So now I substitute 57 inside here to find down the length. So we know that the width equal to W plus 18, which is 57 plus 18. So I have 7 plus 8 is 15. K1, so it's 2 plus 7, the 5 is 7. So that is the length and the width. So this is our answer. This is the width. And this is the length. I mean, this is the width right here, and this is the length right there. This is the width. I mean the length. I must twist them around. This is the length, and this is the width. Let's look at another example. So a jet plane travels 1950 miles in 3.9 hours, going with the wind. On the return trip, the plane must fly into the wind, and the travel time increased to 5 hours. Find the speed of the jet plane in the still air and the speed of the wind. Assume the wind speed is the same for both trips. This is an example of a uniform motion. And in this case here, we deal with a distance problem, the distance, rate, and time problem. It's in short, it's called a distance problem. So the problem asking us to find the speed of the jet plane in the speed of the wind. So that is we have to solve. So first, step 2 is I'm going to let R, any letter you like, stand for, let's do X. Let's do X. I think I like X better. Let's do X. And you used to with X. Stand for the speed of the plane in still air. And let Y to be the speed of the wind. Okay. Step 2. Step 3 is when we try to translate everything into the equation. Now we learned that we know that the distance is equal to the rate times time. That this is what we know. So the best way to do is we're going to organize what we know from the problem by putting a table. So I just import a table that I created ahead of time. So we have the table, so the way when you translate, you put it in there nicely, and you can see how it's work. So now look at our problems. We actually have the plane go with the wind and the plane go against the wind. Alright. If you read the problem here, I have a jet plane travel the same distance. When they go with the wind, it's go faster, so it takes us only 3.9 hours to get to our destination. And when they go on a return trip, we go against the wind, the one that takes longer time to travel the same distance. Pretty much that's what they say. So you actually have two equations. One go with the wind, one go against the wind. So let me label it here. So this one will be this is go with the wind. And the second one will be go against the wind. The second box stands for the second. The first row is with the wind. The second row is against. To blue for with the wind. The distance. The distance is 19. Oh, it's the wrong color, blue. The distance is 1950. That is distance. It's the same for both of them. So are you read right here? It's the same for both of them. Now, when you go with the wind, we have the speed of the plane and the speed of the wind. And we go with the wind, so the direction of both planes are the same. So it should be x plus y. Okay. It's imagine like this. You have a plane. I don't know if we could draw a plane. You have a plane. And it's go, and here is the current of the wind. Okay. So when we go with the wind, the plane go this way. So if x stands for the speed of the plane, and the y stands for the speed of the wind, you have x plus y. The time will be 3.9 hours. Now, when you go on the return trip, you go the wind still go this way, but the plane going that way. The plane go back on the return trip. So you go against the wind this way, right? So you have x minus y. And then this here we have 5 hours. So now we know that a distance is equal to rate times time. So now based on what we have, the first equation, which is with the wind, we have 1950, equal to the rate, x plus y times 3.9. And then the second equation we have 1950 equal to x minus y times 5. That is the two equations that we get based on the information that they give us. Now I'm going to simplify the equation a little bit. I'm going to simplify this equation here a little bit. I'm going to simplify. I have 1950 equal to 3.9x plus 3.9 y. And then the second one we have 5x minus 5y. Now let's see. I see that this 1950 is divisible by 5. So I'm from the equation 2 here. This equation here, I'm divide by I'm going to take this second, let's call it this first equation. Let's call it second equation. I'm taking I see that the second equation here is divisible by 5. So I take the whole equation here, divide by 5. So the second equation will now become, take divide by 5 here. 5 here. And 5 here. So I have x left minus y. Over here, I take 1950 divided by 5, I have 390. So our system of equation here, I can rewrite this again. I have the first equation just copy straight down. And the second equation, we simplify, we have 390 equal to x minus y. Okay. And then now step 4 is we have to decide which method we want to solve for this system, either using the substitution method or addition. I like to use substitution because I can solve for x easily by plus y both sides. I'm taking the equation 2 and just solve for x by plus y both sides. That's easy. So the equation 2 become x equal to 390 plus y. So here is equation 1, here is equation 2 when we solve for x. So you see I have one variable that in terms of something else, I can substitute the x value inside here to solve for x. So I take the equation 2 here in terms of x, put inside equation 1. So I get 1950 equal to 3.9 times x. But x is, here's x. X is 390 plus y equals to 3.9 y. Now I'm going to distribute this. So I take 390 times 3.9 equal to 1521 plus 3.9 times y is 3.9. Then bring this 3.9y down. Over here, bring this number down and solve for x. And combine these two together. So 3.9 plus 3.9 is 7.8y. And then to solve for y, we minus 1521 both sides. 1521 both sides. Now 15. So I got, let's see, this 9, 2, and 4. Now this of a y, I divide by 7.8 both sides. Okay. So y equal to 55. If you want to divide this here by hand, then put 7.8 outside. Right here, I can put a dot 0. And before you do anything, I will move this decimal to the right one time. So the problem becomes 78 divided by 4290. And then see 78 go to 42. It's too small, can go in there, but 78 can go to 429. Let's see how many times. We probably do it roughly you have 4 too small, be 5. Okay, because now 8 times 5 is 40, put 0 carry 4, and then 5 times second is 35, plus 4 is 39. And then you subtract, there's more space. So I have 39 left, and bring this 0 down. I put 5 because I know right here. So the answer remains 0. So I got 55. That's how you do it by hand. Now you know why. To solve for x, I have to go back here. I know that x equal to 390 plus y, which is, so x, so here's y. We know that x equals to 390 plus y, but y is 55. So I have y 55, I put it there, and you add them together, and you're done. So that's the x value, x equal to the answer.